So in comparison to growth, in which case the graph looks like this, it increases at a steeper, usually steeper level. Exponential decay is going to kind of be reflected across this y-axis. It's going to look like this as your basic form. Okay, so now as the numbers, as x's get higher and higher and higher, the value gets lower and lower and lower. But it never actually reaches, again, that asymptote. So in looking at this, you are going to have the same general asymptote. Okay, so y equals 0 is the horizontal asymptote for your base form, just your generic y equals, in this case, ab to the x. But here the difference is that b now, for the decay model, is some fraction between 0 and 1. Okay, so it's a fraction. It's a value that's a fraction between 0 and 1 here. So really it looks like the following. Okay, so all the same transformations occur on this. The general form is going to be this decay, this decrease. It's like the inverted J form. Okay, and then everything that's very similar to the growth model occurs here. So as you have, if we take our function a times b to the, again, x minus h and then the plus k out front, all the same transformations apply to this model. Okay, again, notice this is the exact same equation that we use for both of these. The only difference here is in the growth model, b is greater than 1. Okay, whereas in this decay model, b is a number that's between 0 and 1. So a couple things will come into play when you're looking at this. The first is just identifying whether something is growth or decay. And so really all you're looking for is the b value, the power or the base of whatever that variable power applies to. Is it larger than 1 or a fraction between 0 and 1? So if I gave you the following. All right, if you had to identify in these three forms here, are these models of growth or decay? Okay, what would this f of x be, growth or decay? I heard one decay. Decay. The base is a fraction that's less than 1. So we are looking at decay. Now, the negative out front is going to reflect it across the what? X-axis of the asymptote on that. There's no horizontal or vertical shifting, so all the transformations still take place, but it's a decay model. Okay, what about g of x? And now look very carefully. And let's go back to the chapter on exponents. What does a negative exponent do? It inverts, flips the fraction, right? So if we looked at this in the form of this decay and growth model, okay, which means our x needs to have a positive power, if we can get rid of this negative power by doing what with the base? We invert the base, right? So really we're looking at 4/3 to the x. And so now that one little adjustment allows you to identify this as what kind of model? Now our base that's being taken to the power of x is a value greater than 1. So this we can now identify as growth. Okay, so be really careful on that. again, check for the negative powers. Okay, and then finally, h of x, is that growth or decay? Decay. 0.15 is smaller than 1, so we're looking at decay. Right, so let's take a look at some adjustments made to this function. Again, it should be kind of a review of what we did in the first section. And I want you to see if you can graph this equation for me, please. So this orange line is our generic decay model, which we need to use because our base is a fraction smaller than 1. Okay, so if we take these points, what kind of shifting is going to occur? Vertical shift goes where? Vertical shift is down 5. So we can take our asymptote here and move it down 1, 2, 3, 4, 5. Okay, so we know that this equation, and what's this equation? Y equals -5. There's our horizontal asymptote. Okay, so now this point right here has moved to, it's 1 unit above our asymptote. Okay, that's our horizontal shift. What happens in our vertical shift? What happens for our horizontal shift? Left or right? Remember, what's value of x gives you a 0 in here? 4 to the right. So we're going to take this point, we're going to move it 1, 2, 3, 4. So we get this point to move all the way over here. Okay, is there any shrinking or stretching occurring? Okay, so it's a stretch. And again, it's not as big a deal in exponential growth and decay because the exponential change is going to even be bigger than the stretch or shrink. But I still want to be familiar with that. Is there any reflection here? No. So really what we have is this generic graph. Again, we could find the y-intercept and the x-intercept if we wanted to using our calculators, but I just want you to get the general gist of the graph from that. So again, no reflection. Okay. And this is, again, pretty much all you'll need to be able to do. It's very similar to what we did in this last example, or the last section. Right, the last thing to talk about here is kind of the modeling, which again, just like with the exponential growth, you need to be able to identify.